Okay, I think we're recording. Anyway, hello and welcome to Moving Monolithic Applications to Kubernetes. Today is February 28th. I'm your host, Chris Nova, and we have the rest of the wonderful community on the call today. We're going to be working on moving some workloads to Kubernetes. So to start off, I go down and make everybody say a quick intro. If we already know who you are, feel free to say if you can give a stand up here. So anything you've worked on or anything you want to talk about today or just any updates or questions you have, this is a good time to throw it out. I'm Chris. My updates are that I am going to try to clean up the repo to kind of explain the use case of the repo and to sort of highlight some of the goals of what we're trying to accomplish on these calls and what we want the desired state of the repository to be when we get done with this whole exercise in the next few weeks, I'm assuming. So next in line, we have Josh Hull.
Hey everybody, I'm Josh. I'm one of the maintainers on the Java prototype app.
Brad. Marco, do you want to give an intro?
Yes, hello there, I am Marco. I'm here to learn more about monolithic apps, running them on Kubernetes, and yeah, that's it.
Okay, cool. Mike, you are up next.
Hey guys, Mike Lang, just in the process trying to move a monolith to something more of a microservices architecture, so hoping to learn some stuff from everybody.
Okay, awesome. Did I skip over anyone? Looks like we have somebody in the Docker HQ room. I can barely see a face there.
Hey, this is John Harris. Yeah, I'm in HQ this week. Solutions architect with Docker and volunteer SRE operation code. And no donuts this week. Sorry, Chris.
No, it's okay. Thanks for donuts last time. Cool. And Dhananjay just walked in.
Yeah. Hi, I'm Dhananjay. I'm the head of products at Hepkio. Very interested in understanding what kind of pain points customers and your users have in terms of taking monoliths and putting them on Kubernetes.
Cool. Alrighty. So this week we have a couple of agenda items. I was going to look at an open pull request. Also, I think it would probably be meaningful if we did a little bit of grooming just to understand what homework we can get done so that I want to get us to a point where these calls are kind of like us gluing stuff together. And a lot of the busy work and heads down stuff can be more of like an exercise of, hey, I worked on this week. Here's what I did. And now let's go try to turn it on and see what happens, which is pretty much exactly what we're going to get out of our demo today from Josh, who's put a lot of work into some pretty exciting stuff in the Java prototype app. So Josh, do you want us to go through and look at issues and pull requests first, or would you like to demo first? Because I'm kind of thinking there might be issues and stuff that comes out of your demo.
Yeah, we can demo first. I think it would be a good segue then into the PR that's in place for the schema migration.
Okay. Do you want me to screen share, or would you like to take the reins?
I'm happy to do the demo. Yep.
Yay!
Which, just means that I'm cursed and it'll probably fall over, but I will do my best.
It's okay. We all are here to help you out.
That's right. Let's see. So let me know if you guys can see my screen.
Yes.
Okay, great. So I want to kind of give a high-level approach to what I did to try to get this running in Kubernetes. So I am on a fork of the Heptio Java prototype at my repo, and I've added a considerable, I'm in the charts branch. And I've added a considerable amount of information into this portion of the README for cloud deployment. So the approach that I took was that I want to mirror what we would see in a production setting today. Maybe we have a production application that is running on bare metal or virtual machines, and it is, although it's a monolith, right? We still have maybe the database running in a separate virtual machine or cluster. We have the front end that's running in a cluster. or independent on VMs. And I wanted to mimic that. So the deployment is dependent upon Helm, which, if you're familiar, Helm is an application manager and deployment manager for charts and applications in Kubernetes. But rather than taking the best practice of coupling these with a dependent chart, including the MySQL chart within the parent chart for the Java prototype, I've actually created two separate deployments, one of which leverages the stable MySQL chart that is in the Kubernetes chart repo. The reason for that is I wanted to get as quickly to a working state as possible, and I didn't want to be in a situation where that dependency and that coupling caused problems.
Okay.
So anyone who wants to take a look at the repo, they're welcome to. This is a Google Cloud platform-centric build. Most of the instructions favor that. There is, however, a build spec.yaml that is merged into master if you prefer to build within AWS. So where we are at this point, our developers have released the product. It is now available. The front-end application is available in a stable container. And our build methodology, either using Google or AWS, has released an image that we are consuming. So if we look at the YAML for the, let's see, I want to make sure I'm in the right repo here. Deployment. I can look at the values, and I can see that I am pulling a tagged image of the Java prototype in a Google Cloud container registry at my specific location. So that is already built. It already exists. The demo now begins assuming that that is stable and released into a private repo where we can consume.
How did you build your image?
With the cloudbuild.yaml that is in the master, or in this branch. I guess we removed it from the master branch based on the request to have buildspec.yaml for AWS in place. Okay. But we can certainly merge it back in if we're interested in having an Azure version, having a Google version, having a AWS version. However, we want to take that.
So we would be shipping our source code off to the cloud. They don't compile our code, or do they compile the code?
Essentially what they are doing is taking a Docker builder. We are building with the flag of the Docker file that's present in the repo that's consumed by the builder. We're tagging that, and then with the image label, it's actually pushing to the project ID in question. And we reviewed our Docker file in previous runs, but we can see here it's a two-stage Docker file where we are using Maven as the builder. We're copying the entire repository into the app directory, and then we're packaging with Maven. As a result, then we have the ability to copy from the build container our jars, however many they are, in this case there's only one, into our app. And then we are passing these environment arguments, which I'll show with the demo, so that when this image stands up, it's looking for those respective environment and variables and consuming them in order to run the app. Okay. We have some other information in here that we can certainly discuss later, but it's not relevant to the demo currently. So let us just step through the walkthrough as it stands. So we have some environment variables we're wanting to export. The namespace, the deployment name, the connection password, and the connection user. In this case, I'm going to echo them. I think I've already set them. I have not. Great. That's a clean one. That's great. So I will copy to the comments. And rather than password, let's just go with FTO. And then we can export the remainder of this. This last export is simply recognizing that this is for a community purpose. Anytime you're deploying a persistent image to the cloud, the size of that persistent disk affects the billing and the metering of your solution. So we're not really interested in consuming a gig of information on this. We're going to tear it down as soon as we're done. But a gig gives us enough to start. The default, if you omit this, is 10 gigs.
Okay.
All right, so now that those are exported, I can install the backend deployment. So again, I'm using the stable MySQL deployment. This is very similar to Docker Hub. If you just use the standard repository, this is going to go to Kubernetes/charts, identify where this stable MySQL image resides, and deploy it from that repository. So we already have the Java namespace or Java prototype namespace, but let me use KCTX to look at my clusters. I am on the cluster I'm interested in. Let's use KNS to determine which namespace we're interested in, and there it is. I have Kubernetes aliased to K, so I'm going to be using K going forward, but it's easy. It's the equivalent of kubectl, and we will get pods. There are no resources in this namespace, so it's clean. So we will now install based upon the environment variable set.
And that's just installing MySQL.
This is just installing an empty MySQL against a persistent volume using a Google persistent disk. So that's a 1 gig disk that's been spun up. We can knock this MySQL pod over, and when Kubernetes reinstates that pod based upon the replica definition of 1, it will connect to the persistent cluster with the data preserved. So let's watch our pods. So right now our pod is running, but it's not quite ready. It's still instantiating. And there it is running. So I am going to use the tool kpoof. I'm sorry. There we go. So it's asking me which namespace. I can default to the context that's already set. There's only one pod number, so I can default again. And this is now forwarding the relevant open port to my local host. Why am I doing this? Well, I don't necessarily want to SSH into the node. I don't want to do manipulation aside from the pod, and I certainly don't want to expose my MySQL instance to the internet at large. So this is a secure connection from my local host to that MySQL instance. So now, with my pancake.
What is kpoof?
So in the README, sorry, let me make sure I'm in the right location here. These are our cloud native dev tools. So kex is an opinionated prompt to exec into a container. Kpoof is port forwarding. Klog is log following, or just logs in general if you don't want to follow. And cud is an instant deletion of pods to simulate a disaster.
And these all come out of Farmotive, which is where you work?
It's a side gig, yes. But
Awesome.
yes.
Okay, cool. Sorry.
So it's completely open source. This is just if the tools work for you, great. If not, no worries. It just gives me an easy opportunity. If I have 90 pods in a namespace, I can quickly select them. I am not a fan of using a third arm, right? If I can do everything from the keyboard and not grab the mouse and copy and paste into the buffer, that's the whole purpose of these tools. So it allowed me to do that forwarding without necessarily copying the full string that represents that pod, and then port forwarding with kubectl port forward pod name.
Cool.
Yeah. So we are forwarded. I'm going to open my pancake again, and we will actually look at the secret for the MySQL root password.
Okay.
So that's the secret. Obviously this is recorded, but it's temporary. We're going to nuke it soon. And if you are on a Mac, you definitely want to do 127.0.0.1. Localhost will not resolve.
The string localhost will not work, but if you actually hard code 127, it will?
Correct.
Interesting.
So we can test the connection. We are successful in our connection.
Right.
And now we can see that we generated the Java prototype schema. From here, we can import from the repo in question, Java prototype.sql. So essentially all we're doing with this is a very brief table create argument for get requests. So if we do that, it's going to throw errors which we can ignore. And we can see we have an empty row set with the headers of ID, timestamp, and hash. which is what our Java prototype application is going to look for. So, okay. Now we can continue with the deployment. So we've deployed MySQL, we have installed the schema, we've installed the database. So now we are on the section deployment 2 for the Java application. We've already set the variables that are important to us. So now we can install from that chart repository database Java prototype.
Somebody who just joined, can you mute your microphone, please?
Yeah, my name is Carlos Maldonado. I joined 2 weeks ago, but I couldn't do that in the last meeting. A month ago then, because it's bi-weekly, I think.
Okay, so the pod was already present on the node, so because we didn't make changes to the image, it stood out very quickly and it's running. So now we're going to kpoof again, this time looking at that pod, and we're going to forward to localhost. So now within our browser, go away. We can
It's probably still bootstrapping. Usually that Spring Boot takes like 10 plus, yeah, there you go, success. 10 seconds for it to register and set itself up.
Yep. So now we want to watch the logs within that container. And the reason that we're doing this is to see the behavior of both writing the hash and the consumption of the memory of this very well-written, noisy application. So we're going to take a look. We're going to follow those logs.
I don't always write applications that break, but when I do, I do it well.
So we can see here that it is writing hashes. It is successfully writing to the database. We can refresh here. Whoa. Oh, of course I killed the, sorry. I need another window. Oh, bummer. Sorry, 2 seconds here.
You're good. This is good stuff.
Where was that? There it is.
And you don't even have an egress set up for this database, so even if we had the password, we still can't even route to this DB.
And we can see 4 rows and tables. So now let's hammer the thing. We need that one. We don't need this one. We can reinstate it later. And now we can see within these 3 windows, we are writing to the database, we're handling the connection, and it's continuing to curl against that and create successful writes to the database. And if I do this one more time, and I use my port forwarding, I can refresh this and over time see these successful writes load against the table. So that is the sort of hammering together, if you will, of these very disparate solutions. For anyone interested in the manipulating the application. I do have instructions on what to do to sort of follow along and create those logging followers, the port forward, the argument to do an infinite loop of curl against localhost. And then this is the piece that I really encourage our team to look at over the next few weeks of putting the liveness and readiness probes in place. So the reason why this is standing up successfully, if we look at the deployments, is that we have this section commented out.
Got it.
And that concludes the demo.
Great job. Like, round of applause. That was rad.
Like a gem.
Thank you.
I
So
think.
I will stop sharing, and Chris, you can take the screen back.
Okay. I'm gonna just let us kind of talk without a screen share for a second. I've got a few follow-up questions, and I want to give folks here a chance to ask questions as well. But overall, this is a great starting point. I think we should merge this in to master, and at least use this as like our first step in the direction. And if we want to get into, maybe we want to replace like the way we're building images, we want to like segregate that into cloud subdirectories, or like, we can start to iterate on this stuff moving forward. And then I think one of the big things that I would really like to touch on is, other than the liveliness probes and the readiness probes moving forward, is going to be how do we handle ingress for our application? At some point, it would be really great if we could go and we could explore getting ingress set up, using an ingress controller like Contour, maybe even going and trying to get a domain with TLS certificates up and running and exploring that whole process as well. Mm-hmm. And then I also think at some point, it would be nice to figure out how we can automate the database and actually migrate our data from what's running in EC2 now to a Kubernetes cluster. So those are my big three things. So the probes, ingress with TLS, and migrating data and doing a live migration. Does anybody else have anything they want to add to that for next steps? Scott, I see your hand up in the air.
Yeah, hey, I wasn't sure if you would see me because I think there's more than 5 people on the call, but hi, Chris. How about, I know there are a lot of areas to cover, but how about, since I think, if I'm this is my first join, by the way. Hello, everyone, to this meeting. Thanks for inviting me. A lot of people are concerned about state. Which makes sense. And I know, Josh, you're using PDs because I think that comes standard with the MySQL chart. But how about adopting one of the charts that uses, especially since it's not tightly coupled as a subchart or a dependency, rather, how about getting into the stateful set mindset? Not mindset, but as an example with this, since I believe this is supposed to be, if I understand the overall idea of these calls, is to help migrate legacy apps onto Kubernetes. I think those are some of those are amongst the largest concerns by people out there. They're either going to be using a hybrid solution and using, like RDS to manage their databases, or they need some real assurance that their databases are really going to be secure. Do you know what I mean?
Yeah, that's a good point. The demo was a quick hit. How do we actually get this thing to run, right? So you can look at the definition within the chart and determine the tweaks that I've made, right? It does require a manipulation of Java ops. It does require an extended request for the pod to stay lit, which we knew was the case. But you make a very good point, right? If that individual disk dies, or if that pod or node becomes unresponsive, our solution fails. So if we implement a replica set and we extend this to be a controller and worker scenario with databases, I think we'll be far closer to production reality, given your suggestion.
One of the things I would also like to look at moving forward is, so in this case, we have a Helm chart which answers how we get some arbitrary version of MySQL running, but it very much does not answer how we operate MySQL moving forward. So if we were to, if we wanted to explore like what like a potential MySQL controller would look like. So if we had a MySQL controller like we have an etcd controller, you know, what would that look like? And if there's some software that comes out of that, then so be it. But I think really taking advantage of the controller pattern to really like lock the system down would be something for a future call, for sure.
Super quick question. What kind of database interactions are you talking about primarily? Backing up from an existing production database, or do you mean setting the initial schema, or all of the above?
So in this case, it's all of the above. We have, Josh had his own MySQL database that had like less than 100 records. There's actually a real MySQL database running on a virtual machine in Amazon that's live. That is just playing the role of our legacy app. And then I had another idea last night I wanted to run by everybody on the call, which was right now all of my blogs are running on virtual machines that are like 4 years old. It might be fun to actually, after we get this process like hammered, like to actually really do a real live migration of a real live site that actually gets a lot of traffic and kind of watching that happen real time.
So what's really funny about that, I hope I'm not taking up too much of the time space, but so I had done something with that fairly recently, some of them with Josh actually, and looking back, my costs have skyrocketed. Clearly, we don't move to Kubernetes because it's less expensive than something like Linode or, you know, DigitalOcean, right? You move there for resiliency and for many other reasons. For those other projects of mine, I'm extremely tempted now to essentially compress them into HTML and serve them directly from storage. So it would be a cool exercise, but I wouldn't kill those other legacy projects too soon.
Yeah, and I mean I want to move into Kubernetes because I want to dog food it, and I think it's a good example. Like right now I'm getting about 6,000 hits a day, so I mean we have a real chance of like really having a true outage. I mean, it's my blog, so it's not like anybody's going to lose any money or anything, but it's just a good opportunity to kind of play with fire.
Absolutely. And you're a person whose blog at this point is gaining a lot of traction, so that's a very good example. But I just meant in general in this conversation, maybe something for others to keep in mind.
Yep. Great point. And you're definitely not taking up too much time. We want this kind of stuff to happen because that's the point of the calls.
Cool. Maybe if you don't mind, one other point that related to your last question about the database restoration and database controlling. In general, from application architecture point of view, I don't want to be extremely opinionated, but I think there is a prevalent opinion that the applications who rely on the databases control their schema. And so it would be good if the application itself managed the schema. But in terms of the data, I would love to hear from other people their ideas about this, because very recently I was thinking, well, you know, a Kubernetes job would be a great thing for this, right? And so set up a job, but I never packaged the job with the Helm chart because it would have to wait ultimately until it knew the service was ready to accept the restoration.
Yeah.
So Chris, I think that's a fantastic segue into our pull request.
Okay, so let's look at the pull request. And then Scott, just real quick before I lose my train of thought, we did talk about potential migration strategies for MySQL on a previous call. Okay. One of the things we all kind of shook our head to was setting up a replicated master scenario that would go from our legacy environment to Kubernetes, and then doing the old DNS switcheroo. Official infrastructure terms there.
Got it, yeah. Cool.
Okay, and then I will pull up the pull request now. So let me share my screen.
By the way, I think DNS switcheroo is a really better official term than blue-green. Just saying.
Yeah. So we want to go to github.com/heptio/Java prototype. And I have no idea what this pull request is. So I was planning on all of us kind of looking at this thing a little bit blind on the call. So we have this PR is intended to resolve number 18, which is while testing this error occurs, unable to query table doesn't exist. the minimal schema necessary for the app to fully function for local testing with the Maven build step. So here's our schema defined. And is this a pull request to populate our schema? What is this thing doing?
Right, so this is exactly what Scott is intimating, that we allow the application itself, the binary, to generate and create the requested tables.
Awesome. And that's what this is here. Here's our MySQL data. Is there actual code that's going to do this, or how is this going to work?
So that's the Flyway runtime that I have no familiarity with whatsoever, but I trust that the submitter of the PR might be able to shed some more light.
Okay. Interesting. And I'm assuming that's what this bit here is, this file.
That may be for the Docker Compose version.
Okay. Let's see what he says. Says Docker Compose up -d, Maven clean and Flyway user equals root, Flyway password equals root, Maven Spring Boot run. The MySQL Docker image creates the Java prototype user.
Now that there's a Helm chart, would it be good feedback to the submitter to form this into a Helm chart, or maybe that could be something that someone else on the call who's more familiar, Josh, for example, or actually, I'm sure a bunch of you guys and girls know about Helm, but this person didn't, I don't think, connected it to a Helm template, which would be a good idea.
Yeah. Well, I think definitely getting into whatever flavor we agree on as a team we want is a good idea. We've kind of like passively adopted Helm, which I'm completely fine with using Helm, but I still figured we should at least ask the question for the broader community, like, do we want to make a working agreement that Helm's going to be our lowest common denominator here?
Either that, or I think we could very effectively have branches that approach it from different paths, right? One is a local build with Docker and Docker Compose, where you can run it locally and kind of test the solution. Another is using Helm, and it couples everything together from a deployment standpoint, but not necessarily from a microservice standpoint, and let people choose the path that works best for their organization.
Okay, so maybe we would like break down the sequence of building our app into like 3 larger steps, which is like building the binary itself, building the image itself, and then running it in Kubernetes, and offering different implementations of each of those steps.
Right.
For at least for the chart, the Kubernetes charts repo, the rule of thumb is applications should not depend on Helm. I think the exceptions are if your applications are Helm applications, like controllers and so, or Helm plugins, for example. And Helm is an optional method for package management, essentially. Application package management only. So I wasn't suggesting that Helm should be responsible for doing the work, but that any of the values set, for example, usernames, passwords, they get set as environment variables that are read as secrets that you're expected to create, something like that. You could even have your Helm chart create those secrets as long as you pass those values to the set command or something like that. But you wouldn't need Helm to run the application. I believe that's the none of the applications within the central repo have that kind of tight coupling.
So, and I think that this also brings up a good point that even though we have the cornucopia of build methodologies, we do not have CI/CD in place. Is this something that we want to have sort of a best practice approach to add CI/CD as a portion of this solution so that people can kind of follow along and choose it if it works for them?
I think having some CI/CD infrastructure in place that follows the same pattern of what I put here, that says, here's CI/CD, and here's an example of it running with Jenkins, and here's an example of it running with Travis, and here's an example, running with Brigade or whatever solution we want. That way, we offer an unopinionated view, but we still offer good research and good science behind this stuff.
Exactly.
And then, users can come in and see what we've done and like get a feel for it themselves and test drive it all. And if we need actual infrastructure in place, we're happy to spin up whatever we need to. Like we can get a Jenkins server going or whatever, and I can issue out credentials to anybody who wants them.
Right. We can make an open call to any CI/CD providers if they just want to give us a path to their solution so that someone can see a working example.
Yeah, I think it's a great idea.
12 YAML files.
Fantastic.
All the YAML. Okay, I'm going to make an issue for that as well, which is to flesh out a basic CI/CD pattern and supporting infrastructure behind it. So come up with some sort of process that says, here's where you can track your CI/CD stuff, and here's where you can run it. And then the CI/CD is just going to be an exercise of composing those other things we just looked at before.
Mm-hmm.
Cool.
Every push is going to create like 9 different build processes. It's going to be beautiful.
Yeah.
Cool. So that kind of answers the how do we go from our repo to Kubernetes. We've got it baked down to 3 larger steps, and if you look at some of the tools, sometimes the tools do 2 out of 3 of those steps, or 3 out of 3 of those steps, or only 1. We'll look at plugging that up to CI/CD. Any other issues we want to pull out of this? I had brought up some stuff earlier. Should we just drop issues in now for those?
I definitely would love to have an issue around tuning, right? I went overboard in my pod description to keep the thing lit, but it would be fantastic to have some observability to what it is actually consuming once it has spun up in order to optimize the pod usage of the node resources.
So we want to monitor like observability of the application? Is that what we're getting at?
Right. So, we could bring up the flavor of choice for looking at current consumption versus peak consumption. But the pod as it is overbuilt. It's got too much memory allocated to Java ops, and it's got too much memory allocated to the resource spec definition. And that is, again, it was a hard, dirty, fast way of getting this thing to stay lit and work. But ultimately, if we're going to promote this to production, right, in theory, we would want to tune our deployment and our application definition as best as possible so that our horizontal or vertical scaling is using the resources optimally.
Does that look okay?
Yeah.
Cool. We said the magic word, observability. Which are we?
The word of the week.
Yeah, are we there yet? Or I mean, we're biting off a lot already. I know I want to get there and I want to cross the observability bridge, but I'm just wondering, are we there yet?
Well, quick question. I saw a lot of information spit out into the logs. What else would you like to observe?
Well, so I guess the first thing I would like to observe is the logs are kind of not useful. So by sort of design here, they spit out some just arbitrary, like whatever the built-in JDK memory packages, but it's not really given us a good idea of how much memory the app is really using, what the garbage collector is doing, and are we on the verge of breaking? Like we don't really have a good way of like saying this is a small problem, a medium problem, or this is like a critical problem.
I see. So the signal to noise ratio is completely skewed.
Yeah. So this, to give you a little bit of backstory here, we've kind of gone out of our way to make this application as horrible as possible.
Okay.
Yeah.
To match production.
Yeah. Well, and the idea is that if we can containerize this and run this well in Kubernetes, we're going to face most of the one-off kind of weird issues that you don't see in mainstream legacy discussions.
Yes, and is the idea though to help the application become a better cloud native application, or is the idea to truly lift and shift and just help the organization understand how they can get to the point where they can begin to do that?
I think it's a little bit of both, but it's probably mostly lift and shift. Like we could very easily fix our application just by commenting out a few lines of code.
Right.
But that kind of defeats the whole exercise here. So I think it's mostly like in a situation where it's going to be a really big pain in the ass to adjust our application. How, as an operator, are we going to lift and shift this thing?
And Scott, and for others that have joined in some of the more recent calls, this is the first time as a community we've seen it running in Kubernetes. So we have made attempts to get it across the line before. It runs successfully in the VM because it has an unlimited amount of resources per that virtual machine. But as far as fitting it into a pod and getting it to relate to the database and whatnot, we're crossing that threshold now. And so it may seem as though this was kind of an elementary exercise. And in part it was, but to Chris's point, it would be very easy to refactor this solution so that it defeats its own purpose. And that's not the goal of the exercise, right? We want to make this as production-like as possible, which includes having some legacy issues carried forward.
Yes, understood. That's kind of what I thought. I was just making sure. Cool. I'm excited. I mean, I don't know how many of the rest of you are involved in helping to do. I know Josh is, only because we work at the same place, but I don't know about the rest of you all if you run across these kinds of things often. I know that it is a pain.
Yeah. And I think we're trying to kind of take a scientific approach to this, knowing that it's kind of annoying and it's hard and it's noisy and confusing, and at least trying to poke at it, make sense of it, make some good observations and do some quality science on it. And that way, when we do get into these conversations, like you have a little bit more of a bargaining chip, like this can work this way and here's the data to back this point up.
And if folks want to contribute ODAs or similar things that make otherwise stable applications just kind of fall over, we're more than happy to introduce that into the mix and solve for it, because in reality that does happen, right? We have not predicted what we can't conceive of. It occurs either through load or through some other means, and we just kind of have to work around it. The more stable and less brittle we make this, the better, because everyone who can consume the results will benefit from it.
Yeah. I mean,
I've got them, but I think that the problem, though, is largely those who are doing it are doing it with proprietary code and data, so it can't really. I mean, I would love to say, hey, here's this stumbling block that I have, but I don't think that that's really possible, unfortunately.
But is it something that you could emulate if you could see the error that it's creating? And you know, maybe the community doesn't want to go that route. I just think the more that we make this production-like, the better, as far as the exercise is concerned.
If somebody could, go ahead. So I'm sorry.
I was going to say, the whole point of the repo is to serve as our, like Josh said, like our emulation. Yeah. So if there is a specific problem you want to test for or something you want to see, like obviously we're not going to be able to emulate intermittent bugs that your specific app is facing that nobody can explain. But what we can emulate is, here's different approaches to solving these common problems. And I, as a software engineer, was able to encapsulate one of these problems in the repo, and now other people can try to solve the problem according to how they want to do it. Like ideally, this is a runnable bit of documentation that will turn into a library of, here are like concerns that we came across, and here were the various solutions and what we discovered for each one of them.
And I strongly encourage anyone who's interested to kind of follow what is in the master branch today, right? The VMs are running. Chris has shown us her Kubicorn instance, as well as the VM instances where the app is connecting to a database. But that schema didn't exist. There were no deployments. There wasn't even a container until a recent merge. So if anyone wants to kind of do this on their own and follow the approach that I took, or go a separate approach, I strongly encourage it, because I learned as much from Chris's crazy app that she intentionally wrote to be crazy as I have on any other application I've migrated to production.
Yeah. I would say the one thing that I just want to remind everyone of is, as we are contributing code to the repo, try to do it in a polite sense where you realize there's going to be more than one implementation of whatever problem you're specifically solving. So if you introduce a new like feature to the Java code, like introduce it as a one of many controllers. If you introduce a new build step, introduce it as one of many potential build steps.
And the beauty of containerization is that for each one of these weekly calls, we can take a build that has that odd code, right, and abstract it out in a separate branch, build it, run it, see how it implements, which would give us a very good perspective on rollback, right? How do we get back to stable from this new release that has introduced bugs or issues?
Well, one very large, but small idea, large example is when you have extremely large data sets. This is something I ran into very recently, very, very recently. It not only causes problems, but it extends the troubleshooting time when it takes a half an hour to restore a database.
Which brings up a great point, right? Do we want to actually implement an ETL intermediary or middle layer in our solution so that we can repeat the process of migrating from the VMs to a new deployment?
Yeah, but that's not actually, that's not, I mean, that's an automation solution, and I do have an automation solution, but the problem is that there are additional problems that are caused when you have larger data sets within a database on Kubernetes.
Like, can you give us an example?
Yeah, one was in order to do what needed to be done, initially I was doing ETL basically directly, by either kubectl copying or just piping the data into a restoration process, essentially basically like a PV monitored Zcat, restore process. I had also tried just simply fully expanded restore file copies, which have their own problems. It's a little more fragile, but it's faster. It can be up to 10 times faster. But in either case, the restored total in this case was like, something like 18.5 gigabytes, for one database, and we want N of them, So the problem was resource requests initially, or that was one of the solutions, was resource requests. But part of the problem as well is the other applications that need to connect to it often need to increase their resources to connect to it. So those are, and tune their, depending on what kind of application. This one was a PHP application, a PHP 7 application. So some of the times the configs need to be tuned. Sometimes your database configs need to be tuned. This is something pretty similar to what Kelsey had been mentioning for a long time about don't use databases. He's not saying don't use databases, but it kind of sounded like that to a lot of people. And very recently in an interview, he said, well, I'm not saying don't do it. Kubernetes can certainly handle state, but you have to really know what you're doing. So not only do you need to be an application developer, you also basically need to be a DBA. And I think that that's a fair point. It's one of the things that should at least be discussed when we're talking about state in legacy applications, especially if you have larger data sets. Those problems compound.
Yeah, and I think this is the laboratory we want to start poking at those concrete problems right there. Like, if we can do it with 5 gigabytes, great, but let's do it with 500 gigabytes, and let's put a cap of 3 seconds on that or something.
Right.
Let's start to kind of put some numbers behind this and really stress what we can do, what Kubernetes can do, and what these migration tools can do. And I bet we're going to discover real quick where like the main voids are. And I bet there's going to be room for some exciting new projects to come out of here.
And Chris, what do you think about an issue around securing our application, ensuring that a network policy is in place so that there's no communication with the pod outside of the ports that we respect, and making sure that there isn't drift?
Yeah, I think that's a great one. I think if you want to, I can add it real quick, or if you want to add it. Let's see, what do we want to call this?
Securing the application.
Securing the application. And can we lock down the application in case? And then you can go through and what that means concretely, add it to the list there.
Perfect. I know, the interesting thing is that even though the applications themselves are legacy, Kubernetes is rapidly increasing in its feature set and its availability. So those of us who kind of came on at a certain time are now relearning network policies and relearning roles-based access control when that wasn't something that we necessarily had introduced when we encountered Kubernetes. So everybody's on their own path, but the more that we can secure the application, right? I think Joe had some really good insight on what took place with Tesla's Kubernetes cluster recently. So definitely we could take a look at that.
Yeah, I think that would be great.
I'd love to hear about that later, by the way.
He did a TGIK on it last week. If you want to watch the video, but yeah, I just kind of poked at what was the exploit for the Tesla breach and how do we prevent that from happening moving forward.
And I
That's
believe
amazing.
Specifically the dashboard, right?
Yeah.
Yeah. So we're not necessarily looking at the dashboard here, but it doesn't mean that our application is fully secure, right?
Yeah.
It would be valid, I think so.
Another is, since we're using Helm, there was that recent, wasn't it Joe Beta who mentioned that, Josh, about the recent exploit of...
Linked to a JetStack post that Monolithic wrote, but I think his link was somewhere else off the top of my head. But essentially it was saying that the Tiller API can be manipulated.
Right, if it's not locked down to localhost, it's exploitable.
Correct.
Right. And the exploit in Helm was the gRPC server is unencrypted and it runs in the root namespace. So
right.
you pretty much could get root on a cluster pretty easily.
Right.
That hit a lot of us sideways because many Helm maintainers go right in and no one pretty much was locking that down.
Yeah.
Well, and across the board, the interesting behavior that you see everywhere is that, RBAC is put in place. Well, let me just give cluster admin to Tiller, and then I've solved my RBAC blocker, right? It's not necessarily best practice, so it would be great for this laboratory to extend best practice to the community if we can.
Yeah, which is why I think having these multiple implementations, like here's the one Helm chart, here's the 3 Helm charts with everything compartmentalized, here's static manifests, here's whatever else.
Chris, is the idea, and whomever else, is the idea for this to have a section of these prototypes that include where Java prototype is one of many, or is this just we've chosen Java because it's the most legacy of legacy thing we can think of, and we're going to focus all in this repo?
Yeah, so we picked Java because I just wanted to kind of poke around at how Java behaves in a container, and I felt that most of the larger monolithic enterprise applications, just based on raw internet data, are going to be running in Java. But I think the idea would be that the application, if it does grow, it grows in ways that make it even harder to run. And I think everything around the application that implicitly is also living in the repo is going to be like the science behind the whole exercise here.
That's amazing, because what I would love to see is potentially is a repo like this, or this repo containing not necessarily polyglot microservices, but even just polyglot horrible legacy services that depend on one another, because that's what I see often.
Yeah. And I think, if we want to have Java prototype, and maybe we start coming up with better names for these things, but I'm happy to knock out a horrible application in any programming language. I've been really wanting to get into Rust, honestly. So, and I wrote this in like a weekend. So yeah, we can totally start gluing these things together, because really that's what's going on here. Is we have this weird mixture of stateful and stateless, or kind of stateful or kind of stateless, or sometimes stateful, sometimes stateless applications and they get glued together in really, really weird ways, and trying to migrate those. Again, we're going to kind of repeat the same process of doing the science and figuring out good and bad ways.
And we intentionally injected asynchronicity into it so that it would be sort of a really kludgy, brittle application. So Java is great for both async and kludgy.
Yeah.
I love it.
Have you had a chance to look at the source code yet, Scott?
I haven't. This is my first foray. In fact, I mean, I got a preview from Josh, but as soon as I heard that he was doing this with you all, I was super excited. And he said, well, why don't you join? I was like, okay, great. So I will take a look. Oh, I think I'm looking at it now.
Yeah. So yeah, this application is it's
delightfully horrible. I love it.
Yeah.
It's playfully. Yeah. It's yeah.
Yeah. Hard code the constants. We hard code some algebra here, and we just kick off a ton of threads and try to confuse the garbage collector. And all we do is just write random strings of random sizes to threads stored in memory for some unknown amount of time, and then the thread exits.
I've got an idea of how to make it not worse, but this might go against your theory or it might work with your theory. Just throwing it out here, if that's okay.
Sure. We have 1 minute, by the way.
Static IPs, right? At some point, you can't make that work on Kubernetes. So would you have at some point some kind of a diff between here's the minimal amount of things we needed to change to make this even remotely close to being able to work in a cloud native sense? Or
I definitely think we're going to cross that bridge when we try to interject ingress, and we can add the complexity of having to make ephemeral match or DNS match to something that is hard-coded, just like this memory calculation.
Okay, so I have to cut us off in the name of time. We can continue this conversation in the Kubernetes Slack called Monolith. And we can dig out, we put some issues in. If anybody wants to sign up to volunteer to work on any of these before the call next week, feel free to. If not, I will try to work on some of these, and we'll start the call off next week with another demonstration of what we've been able to do and the progress we've been able to make, and go from there.
Thanks, Chris.
Cool. Thanks for joining, everyone.
yeah, thank you.